Hello, thank you so much for joining us today and welcome to the first webinar in the Clean Energy on My Land webinar series. Today, we will be focusing on the Clean Energy on My Land Technical Assistance Program and clean energy siting considerations for My Land. I'm Jillian Romstall, a project manager at OCED's My Land program, and I will be kicking us off today. Before we get started, I just wanted to let you know that this webinar is being recorded. If you would not like to be recorded, please keep your video off and stay on mute. Please place any questions in the chat as we go, and we'll do our best to answer them. To access the chat, you may need to click the three dots at the bottom of your screen and then hit chat, but it should also just be at the bottom. Next slide, please. Today, we will start off with a brief introduction of DOE's Office of Clean Energy Demonstrations, or OCED, and its My Land program. After that, we will have a short presentation on the Clean Energy on My Land Technical Assistance Program that NREL runs on behalf of OCED, along with a few minutes for Q&A. Then the remaining bulk of the presentation will focus on clean energy on My Land siting considerations using solar PV as a case study. After that, we will have some more time for Q&A. And finally, I will wrap up with some concluding remarks. Next slide, please. So I'm really excited to introduce our two other speakers today. First, we will start off with a short presentation by Ryan Shepard, who is a resilience researcher at NREL and is NREL's lead for OCED's Clean Energy on My Land Technical Assistance Program. And I'm also excited to introduce Dr. Andy Walker, who is a senior research fellow at NREL and will be presenting on clean energy siting considerations for My Land. Next slide. But before I hand it over to our speakers today, I did want to provide a brief overview of the Office of Clean Energy Demonstrations and its My Land program. Next slide, please. OCED's mission is to deliver clean energy technology demonstration projects at scale in partnership with the private sector to accelerate deployment, market adoption, and the equitable transition to a decarbonized energy system. Next slide. We are a relatively new organization funded out of the bipartisan infrastructure law. We have a little over $25 billion in programming, and this slide lists off some of those programs. One of those programs is, of course, the Clean Energy Demonstrations on My Land program, which is running this webinar series, and I will go into a few more details about this program in just a minute. Really, what drives us here at OCED, our mandate, falls into 5 categories. One is being a center of excellence, really serving as a primary office to deliver full-scale clean energy demonstration projects and project management oversight. Second is clean energy and equitability, helping to enable 100% clean electricity by 2035 and net zero emissions by 2050 through an equitable clean energy transition. 3, we're always thinking about follow-on investment. So unlocking and scaling trillion-dollar clean energy and follow-on investment by the private sector in other areas of capital. 4 is to de-risk technology by maintaining a risk-based, balanced, and defensible portfolio of investments. And the last mandate is ongoing engagement and outreach. We want to leverage the learnings and experiences of the private sector, broader ecosystems, and communities themselves to really understand how we can collaborate, get feedback, and partner together to reach our shared goals. Next slide, please. And now if you'll just switch to the next slide, I will provide a brief overview of the Clean Energy Demonstration Program on Current and Former My Land, or CEML for short, which is the umbrella program for the technical assistance effort you will hear about shortly. The CEML program received $500 million from the bipartisan infrastructure law and will provide financial investment, technical assistance, and other resources to advance the widespread deployment of clean energy projects on current and former My Land. Through this program, up to 5 clean energy projects will be carried out in geographically diverse regions. At least 2 of them must be solar projects. These demonstration projects are expected to be replicable, providing knowledge and experience that catalyze the next generation of clean energy on My Land projects. And like all OCED projects, there is an emphasis on economic development and environmental justice, lasting beyond chosen projects. We currently have a funding opportunity open for this project, so I encourage you to read more about that, read the funding opportunity announcement if you're interested in more information about this program. And I will just also say that this is distinct from the technical assistance program that you'll hear about in a minute, which is open to anyone that is developing clean energy on My Land. And now I will kick it over to Ryan Shepard, who will provide an overview of the technical assistance program. And as a reminder, please place any questions into the chat as we go. Thank you.
Well, thank you so much, Jillian, for that introduction to OCED and Clean Energy on Mineland, CEML. Again, hello, everyone. My name is Ryan Shepard. I'm a resilience researcher here at the National Renewable Energy Lab and the program lead for this CEML TA effort. Next slide, please. So again, CEML TA is a standalone and distinct effort from the FOA that OCED is heading up. Again, OCED is more or less managing the intake and is going to award the recipients of the funds. And this TA effort is to really provide no-cost technical assistance to qualifying entities who have questions about clean energy deployment on current and former mine lands. We generally have a limit of 40 hours per applicant. And so the intent and scope of this TA is not to deliver in the weeds, nitty-gritty technical analysis, but more to provide high-level considerations for how to deploy clean energy. And we'll talk a little bit more about the qualifying topics and forms of delivery. Next slide, please. So I did mention that there's qualifying entities who can apply to this TA program. And so those would include governments, whether that's state, local governments, or Native American tribal governments. Community-based and nonprofit organizations are also able to send in applications, as are companies and enterprises, whether they're privately owned or publicly owned, as well as academic institutions. So any of these organizations and entities that are curious about clean energy on mineland deployment are able to apply. And again, they don't necessarily need to be interested in submitting an application to the FOA. They simply have to have an interest and a desire to learn more about clean energy deployment on mineland. And talk a little bit about the kinds of clean energies that are available for that the applicants can request more information about on the next slide. So yeah, the kinds of clean energy that we're able to provide TA for are limited due to the bipartisan infrastructure law, which gave specific statutory guidelines about what those energy forms can be. So as you can see, wind energy is not on this list, but there's plenty of other clean energy forms that we can assist you with, including solar energy, microgrid technology, geothermal energy, direct air capture of greenhouse gas emissions. We can even provide technical assistance on fossil fueled power generation, provided that there's carbon capture, utilization, and sequestration. We can also help you deploy energy storage, whether that's batteries, pump storage, hydropower, and compressed air storage. And we can also assist with advanced nuclear power, such as small modular reactors. And again, these clean energy projects or questions have to be cited on current and former mineland. So if you have an idea that you're requesting technical assistance about, but it's not related to mineland, we're unable to help you with that, unfortunately. But there may be other DOE and OCED programs that might be more applicable. So please don't feel shy. You can send in those requests. We may not be able to field it directly, but we might be able to redirect you elsewhere. Next slide, please. So in terms of the kinds of technical assistance that we're able to help with, some applicants have already submitted requests about high-level site planning assistance. So perhaps you have a solar PV project that you're spitballing and you want to know, this is the amount of acres that we have. Given that land availability, that land restriction, what would the power generation be? And we can run that request for you. If you already have done some of that more preliminary site assessment, we can also help you with some issues that might that might arise further down the project implementation pipeline, such as, well, now we have this this project scoped out. Who's going to take this energy? Because in most cases, mine lands are pretty remote from a lot of the end users, assuming that you aren't providing the energy directly to the mine and the mine operators themselves. Any kind of communities that would be purchasing this power are probably going to be distant from the power generation on the mine land site. And so we can help you with interconnections, power purchase agreements, considerations for those. Because Bill authorized this program, part of the Justice 40 commitment is making sure that benefits are being delivered to communities. And some of the benefits that Bill specified for this clean energy on mine land program are ensuring that there's a low levelized cost of energy, a high number of jobs that are being delivered, as well as a reduction in greenhouse gas emissions. And so if you are curious about how to demonstrate that this potential project could deliver on those benefits, we are happy to run kind of a community benefits planning process, some high level considerations for doing that. And part and parcel to that is also making sure that you've captured workforce and economic development opportunities. Next slide, please. In terms of the forms of delivery for this TA, most of that is probably going to occur as a phone conversation or as a Teams meeting conversation, especially when we're doing the intake and kind of figuring out what your specific needs are for this TA. If we are running more of a site feasibility assessment, that will probably be in the format of a PowerPoint slide deck, like a presentation. And we're also happy to share with you memos and PDF documents, such as fact sheets that outline best practice and considerations for your own process. Next slide, please. So this slide here shows a screen capture of our NREL website that contains written information about this technical assistance program. You can use the QR code here on your screen to access that website. And if you have any questions that you would like to send directly to us about TA, or if you'd like to actually get involved in getting applications submitted our way, we're happy to help you with that. The email address for the CEML TA inbox is there on your screen right there. And some of you on this webinar might have already submitted questions to us. And we are working on processing those questions as quickly as possible. We are kind of putting together the plane as it's flying, so to speak, finding experts who are able to help you with addressing your requests. And so if you are kind of in this waiting space, we appreciate your patience and we will get back to you as quickly as we can. Next slide, please. Yeah, and so we're going to have a brief Q&A session here. If you have any questions about the CEML TA program, I'm happy to take those. Looks like we also have some questions here in the chat, but if anyone wants to ask their question directly, you're more than welcome to come off mute, but otherwise I'll turn to the chat.
Hi, Ryan, this is Gail. I've got some chat questions that I've been reviewing as you've been speaking. Thank you so much for presenting. Some of you may recognize my name and me. I am leading the CEML program for NREL, and Ryan is leading the technical assistance program, so I greatly appreciate his help with this. One of the questions that we've got, and I'll take a couple from the chat, and then I see there's a hand raised. And so I'll try to go back and forth between those. But Mary Forrest asked, is the assistance available for concept paper submission? Jillian, that might be a good question for you.
Yeah, just to be clear, this technical assistance that we're presenting on right now, This is not technical assistance for the funding opportunity announcement or for concept papers. That is distinct. NREL is in fact prohibited from answering any questions related to the funding opportunity announcement or concept papers. There is a formal Q&A process that we have to go through. So I will drop that email in the chat. So if you have specific questions related to the FOA, then just send them through that email. This technical assistance is available to help you with project development and a lot of the topics that Ryan went over, but they are not able to assist you in the FOA.
Great, thanks, Jillian. And another question I think probably for you is there a federal legislation to prioritize the CEML solar project to connect to the electricity grid?
So I am not aware of any federal legislation to kind of prioritize interconnection of these specific types of projects. There is technical assistance that, I'm not aware of any. I know, so for this specific provision, the Clean Energy on Mine Land program, there is going to be technical assistance for interconnection provided to the projects that are selected. Again, that is through the funding opportunity announcement, so that is distinct from this technical assistance. And that is what I'm aware of at the moment. And Gail, Ryan, jump in if you have additional information there.
No, I agree, Jillian, thank you. And then what if a microgrid is utilizing wind power? Wind power isn't on the list of qualifying technologies, but a microgrid is. Would that qualify under microgrids?
And that is, I'm assuming, so again, if that's a question related to eligibility under the FOA, we are not able to answer that question. You need to submit that through the email that I'll put in the chat in just a moment. However, if that's related to the technical assistance program, I would say that if it does fall under DOE's definition of a microgrid, which I will also drop into the chat in just a moment, then it should be eligible for technical assistance.
Yeah, thanks, Jillian. I would say yes. If the question for technical assistance for the wind integrated microgrid is how to deploy the microgrid, siting considerations for a microgrid, interconnection, getting support for the community for the microgrid, I think we would be able to assist with that. And you're more than welcome to send in an application, and we can navigate that process with you.
Yep, I agree. Oh, sorry, Ryan. I didn't mean to step over you. I wanted to go ahead and hop to William Taggart, who has his hand up. I wanted to go ahead. We've got a few more questions in the chat. We've only got 2 more minutes for this segment of Q&A. We're going to have some more time after Andy talks about siting. And so we'll try to get to all the questions, but with our last couple minutes, William, would love to hear from you. Please go ahead and unmute yourself.
I have. So I'm curious about the whole energy on mine land definition, because in the FOA, it speaks of the 1872 mining law. And I'm trying to understand that law appears to limit on federal lands and only.
I'm sorry, let me just stop you there because we are not answering any questions on the FOA. I'm dropping the email into the chat right now. And you could reach out to that email, but this webinar does not focus on the FOA.
I understand that it focus on the FOA, but I'm more curious about when you say mine land, which is the whole point of your group, what are you speaking of? I'm looking at locations that were used for sulfur mining under the FRASH process that don't appear to fall under the 1872 law. Does that fall within your group or does it not?
So for technical assistance, the definition of mine land is more broad. So just submit an application and NREL will determine if you're eligible or not. But for eligibility of mine land under the FOA, we can't answer that question. Thank you.
Okay, so we have one more question, a couple more questions, but curious, Maddie, if we need to go on with Andy.
We are at time for this Q&A
Okay.
session.
Great, thank you.
Okay, next slide, please. So I'm Andy Walker. Thanks to Jillian for the introduction and Ryan for the presentation. And thank you all for joining us this afternoon. I'd like to talk about siting considerations. Next slide, please. So these are the drivers for siting renewable energy on mine lands, land reclamation, using disturbed areas, a long-term land use, a viable long-term solution for the land use that provides consistent revenue over a long analysis period. Sustainable economic development, stimulate local economies, jobs, revenue, and growth. There's a synergy between solar installations that are using infrastructure even as mining is reduced. So infrastructure here referring to power lines and roads. Renewable energy generation, reduce greenhouse gas emissions, fossil fuel consumption, mitigate climate change. The environmental benefits include restoring habitat, water quality, soil degradation. Community collaboration, engaging local communities, involving stakeholders, energy independence and resilience, diversify energy sources and where on-site generation can enhance resilience. Educational opportunities for workforce development involving schools, universities, trade schools in the area, and a symbolic transformation from extractive industries to sustainable future. So these are drivers that this group has been considering for a long time. Next slide, please. So now we'll focus in on the siting considerations. So here's a list of things that we'll consider in this session. Are we generating power to serve on-site loads or to export power to a utility? Regarding land ownership, parcel size, and within a parcel, how much land, what land might be available for project development? How about the serving utility? What are their policies and pricing if they were to purchase power? What is the existing electrical infrastructure capacity? This refers to the power line running to the mine site from the utility. What are the renewable energy resources at a site? How sunny is it? How windy is it? How about the topology and the topography, the land slope, soil type, water drainage? Site access refers to roads, environmental constraints such as endangered flora and fauna, riparian areas, pollinator habitat, land use planning and zoning, regulatory constraints such as glare to airports and non-regulatory constraints such as views of neighbors. So let's step through these. Next slide, please. One thing to consider is the layers of jurisdiction at a site. Local governments, city and county land use permits based on zoning and planning ordinances, working up to the level of state agencies or tribal governments. There might be environmental laws. California's are particularly notable, or there might be permits that are required by state agencies, and they might be agencies that are impacted by highway use or transmission line rights of way and things like that. Regional transmission organizations or such as PJM or independent system operators such as CAISO or ERCOT in Texas, approval from the transmission network to connect to those grids. At the federal level, permits might be required by agencies enforcing the Clean Air Act, Clean Water Act, Endangered Species Act. For large projects that connect to the electrical system, to the larger electrical system, so a single plant of 20 megawatts or higher, or fleets of systems greater than 75 megawatts or higher would have to comply with NERC and FERC regulations and reporting requirements. And then for projects on federal land, we'd have National Environmental Policy Act. NEPA might result in a categorical exclusion if a solar project is on a rooftop or on a previously disturbed land, or it might require an environmental assessment, and it might require an environmental impact statement, which might require design measures and mitigations. And then there's National Historic Preservation Act and acts which preserve other cultural resources, which would have to be observed on federal land. Next slide, please. So we have a long list of things to consider with siting. Let's work through them by the way of a hypothetical example. So let's imagine this Maximus mine. The facility uses 150 million kilowatt hours of electricity a year, has a total facility land area of 137,000 acres. The mining operations are to deliver high quality products, but in a way that's safe and environmentally responsible and in collaboration with the community. So in pursuit of that mission, Maximus Mine would like to put at least enough photovoltaics and or wind power on their site to power their mining operations. And how much of that would be required would be, if it was photovoltaics, it would require 100 megawatts of photovoltaics. And each one of those orange squares shows how much would equal 10 megawatts if it was at 4 kilowatt hours per square meter per day solar resource. And if it's at 5 kilowatt hours per square meter per day solar resource, it would require a smaller area. Similarly, with wind power, it would require 70 megawatts of wind power to deliver the required amount of energy. If it was 10% capacity factor, it would be the big blue rectangle. 20% capacity factor or 30% capacity factor. So depending on the resource in the area, we're looking for enough of these rectangles of orange or blue to deliver enough energy to offset the 150 million kilowatt hours of consumption per year. So let's consider siting within this study area. Next slide, please. A lot of these siting issues are geospatial phenomenon, so they occur, as a function of geospatial data. And a tool that NREL has developed to help with this data analysis can be found at nrel.gov/GIS. It's this data explorer, and so this is a picture of the most recent version, but in the slides to follow, I'll be using the previous version. Next slide, please. So let's start by considering the land ownership. So the mine property is shown in gray here, and some of the surrounding, the dark green at the top is U.S. Forest Service, so they're responsible in managing the forest resources. The yellow is Bureau of Land Management. So Bureau of Land Management has within their mission accommodating solar and wind projects in the same way that they accommodate other land uses like grazing or fossil fuel leasing. There's some recreational areas shown in the dark orange that we want to stay away from, and some park areas shown in the light green that we want to stay away from. But the uncolored areas are private property, which might be available if we could work out an arrangement with the landowner. Next slide, please. How about road access? This one has a major interstate pretty close by, feeding into a more regional highway that runs from this from the northeast corner of the study area to the southwest corner of the study area. So this corridor along that highway would be good for consideration from a road access point of view. Next slide, please. How about the utility service areas? Let's say that Maximus Mine covers 3 service territories. Towards the north end of the boundary is served by a municipal utility. Towards the south end of the boundary is served by a rural electric cooperative, and the territory of an investor-owned utility kind of expands into in between the two. So all 3 of those utilities would have different policies. Let's say the municipal utility allows self-generation, allows net metering, but doesn't buy wholesale power. The investor-owned utility has a renewable portfolio standard that they have to comply with, so they probably would have an appetite for purchasing renewable energy. And the rural electric cooperative to the south is bound by a contract to purchase power only from their regional generation and transmission provider, so they wouldn't be in the market to purchase wholesale power from our plant. So the policies, regulatory policies, and the economic conditions of the different types of utilities could be important to our siting decisions. Next slide, please. How about the transmission system? So there's a substation on the north side of the property, which is served by the municipal utility, and that serves the major loads at Maximus Mine. There's also a substation coming in from the Rural Electric Association to the south, and the substation at the end of their line. And then Maximus Mine has built their own line between the two substations called an intertie. So this is the configuration, and kind of similar to the road, we would want to site our development somewhere with access to this transmission line, and more specifically, somewhere with access to either one of the two substations, either to the northeast or to the southwest. Next slide, please. How about the topography? We can see it's rather mountainous in the northwest part of the study boundary. And we can also see some water features, some lakes and creeks and things that we might want to pay attention to with regards to the topography. So we'd probably want to stay away from the northwest quadrant of this property just because it's mountainous. Next slide, please. With regards to the streams, these are some guides to protect riparian areas. So the reason to protect riparian areas is to restore erosion and flood control and habitat for animals. The way to achieve that is setbacks and buffers from streams or lake areas. If there have been any levees, drainage tiles, riprap, ditches, anything that's been added to remove those features and try to restore the stream to its original stream flow and control invasion of plants, non-native plants that might invade those riparian areas. Next slide, please. We can look at the land cover from a geospatial aspect. So the northwest corner of the study area is evergreen forest. So if we were to do anything there, it would require removal of those trees, but also that's the mountainous part. The red areas are the developed areas, so the built environment. The orange area is the open pit of the mine. But the tan areas between are grassland, which would be easy to build either solar or wind development on, more or less flat grassland in terms of land cover. Next slide, please. How about environmental restrictions? We do have some areas of critical environmental concern within our study area. Those are the pink areas on the left-hand side. We also have a wilderness study area, which is the light yellow, and then we have the park areas that we already saw in light green. So these are in the mountains to the west side of the study area, so we'd probably want to stay out of those anyway. Next slide, please. How about critical habitat? We already saw the area of critical environmental concern indicated on the previous map, but we also have some critical habitat for fauna and flora indicated on the map. Again, they're in the mountainous areas west of the highway. So this is kind of an indicator that if we stay east of the highway, we'll be able to avoid those. Next slide, please. And the previous disturbed land, a ballasted rack can avoid penetration of foundations into the ground. The most common types of foundations are either driven piles or helical piles, which are screwed into the ground. But if we had a landfill cap that we couldn't penetrate, then we could use ballasted systems. Here's a couple of examples. The one on the left is on Jersey barriers at Joshua Tree National Park, and they couldn't dig there because there might have been archaeological artifacts under the ground. And the photograph on the right is at Nellis Air Force Base, and they couldn't dig there because they had ground contamination. Both of them are ballasted, held down by the weight of those concrete ballast blocks. So if I were to try to do this on a capped landfill, I would have to revisit the agreements with state regulators regarding the ongoing operation and future of the landfill. Inspect the landfill initially to identify any defects, and then repair or upgrade the landfill cap to to correct those defects before a solar was put on it. And then in addition to the weight of the ballast itself, I have to be careful about the installation equipment. It's often heavy equipment that's moving around on the site, and that equipment has the potential to damage landfill caps. So careful design and execution of that installation could avoid that. And then after the system installed, ongoing integrity of the landfill cap and the water runoff, make sure the weight of the ballasted foundations hasn't created any depressions or affected the way the water flows off the site. Next slide, please. And then it could be planted with native grasses and wildflowers that could so you want to minimize the amount of grading and removal of topsoil, minimize the soil compaction, and plant native vegetation. The figure here shows the root structures of different types of plants, but also how they look above ground. And the one that I favor is the one that's kind of right in the middle that has deep roots. So it's more drought resistance, but also a really short grass, so it doesn't grow up. The plants on the right-hand side of this figure are tall enough that they could come in contact with the rack and cause soiling and corrosion, and they could also be a source of fire. And if they got tall enough, they could be a source of shading on the modules. So to introduce the right kind of vegetation and also to maintain it so that other taller invasive species don't come in over time is part of the operation and maintenance of the vegetation management. Next slide, please. You know, we're all becoming increasingly aware of the importance of bees in our life and pollinating all kinds of plants. So ways to have a pollinator-friendly development include establishing native vegetation and pollinator habitat, maintain beehives. One thing I would share is that there was at least one case where a beehive was purchased, but it couldn't be installed because an employee at the site was allergic to bee stings. So just to avoid that that hazard, the beehive was not installed at the site. Address soil compaction, erosion, and noxious weeds. Prohibit application of insecticides, which can affect the pollinators. Next slide, please. Historic and cultural resources. There's designated historic structures, also view sheds. There might be cultural resources, including geographical features such as rock formations that might have cultural significance. The photograph of the cabin here is on a property called Bighorn Mine. Consultation with State Historic Preservation Officer and other stakeholders, including the general public. Basically, the National Historic Preservation Act doesn't tell you what you can and cannot do, but Section 106 of that act describes the process that you have to go through, and that's a requirement for federal agencies. Next slide, please. So now we're on to the solar resources. This slide shows the direct normal solar insolation in the study boundary. And so just to continue with our purely hypothetical example here, the best solar resources are on the south side of the site. Remember, that was flat grassland, close to the REA substation, close to the highway. So this southern part of the parcel is, or of the study boundary, is almost ideal. And if we calculated the 100 megawatts of photovoltaics that we would need for a place with a solar resource in excess of 5.5 kilowatt hours per square meter per day, we'd need 10 of those little rectangles there. So it looks like the study boundary could accommodate that amount of land area. Next slide, please. So this is looking at the global horizontal insolation. It's just another way of looking at the solar resource. So we can skip this slide, comes to the same conclusion. But this map shows the wind resource, and we can see that the wind resource is the best in the south western corner of the study boundary with a capacity factor of greater than 0.3. So we can use the smaller blue rectangles to estimate or illustrate what the area associated with the wind development would be. And it looks like there is sufficient area. And again, it's in proximity to the REA substation. It's on flat grassland. It's close to the highway. So almost ideal location for wind in that location. Next slide, please. So what have we been able to do in the case of this purely hypothetical Maximus mine? We were able to site PV and or wind to satisfy the land ownership, flat topography, grassland, which would be easy to construct on. We found the location on the parcel, which maximizes the solar and wind resources. It's close to the highway, it's close to the substation. We can use that intertie from the REA substation to the Muni substation to serve the loads in the northeast part of the study boundary. We can avoid all those areas of critical environmental concern. We can avoid all those areas of flora and fauna habitat. So in this hypothetical example, we were successful in citing, but more generally, the process would have to consider trade-offs between these things. Like maybe I would have to build a new substation. Maybe I would have to extend a transmission line. Maybe I would have to build a new road or improve the road that's there currently. So it's often a compromise. In this hypothetical example, we were able to get through it pretty much without making those kind of compromises. Next slide, please. So some other considerations: land use and zoning, ensure the land is zoned for renewable energy, permitting and compliance, federal, state, and local permits and regulations, environmental assessment, potential impacts on environment, wildlife, water resources, and local communities. So whether it's a categorical exclusion, environmental assessment, or an environmental impact statement, this NEPA is applicable to projects that are funded by a federal agency, but then, any part of the funding coming from a federal agency, or it could also be if it requires a permit from another federal agency, then in that case, it would also trigger the NEPA requirement. Site cleanup, if there's any hazardous waste from the mining activities, those should be safely managed. Another consideration: endangered species protection, identify and protect any endangered species and their habitats. Noise pollution is not an issue for photovoltaics, but it could be for other technologies, maybe wind power. Minimize the disturbance to the wildlife and local communities. Soil and water quality, prepare the site to minimize impacts on soil and water quality, prevent soil erosion, prevent sediment from running off the site, and water pollution. And then finally, to think about decommissioning. And at the end of a project lifetime, what are we going to do with the equipment? Is it going to be an asset or a liability? Can it be recycled or properly disposed of? So plan for eventual decommissioning of a photovoltaic installation, including reclamation of the site to another suitable purpose or to its original condition. Okay. So I tried to move through that quickly to leave time for Q&A. Next slide, please. I think.
Hi, Andy. It's Gail. I've got a couple questions here for you.
Okay.
Out of curiosity, do you know if the FEMP screening map identifies mineral rights, the FEMP screening map that you showed?
I don't think NREL's offering does include mineral rights, but
Okay.
there's this whole wide world of geospatial info out there. So if you had somebody with ArcView or GIS software, you could combine the NREL data with other data that you might have available from other sources. Like I'm guessing mineral rights are probably mapped by USGS or some other agency other than NREL. So if that's the case, it would take a GIS expert with the appropriate software and stuff, but I think the NREL data could be combined with data from other sources.
Great, thanks, Andy. As I suspected, another question, could you comment on what screening steps are you?
Sorry, Gail, I lost your
Sorry,
audio.
Gail, you got muted by accident. Could you unmute and repeat the
Oh,
question?
sorry. My question was, or the question in the chat was, could you comment on what screening steps are unique to mine land versus screening steps that would be done on any greenfield targeted land? And that question was seconded. And so I wanted to get to it, but I also have some thoughts on it if you want to go, Andy, and then I can chime in.
I think the big one is previously disturbed land. Like, I think like areas like that have been previously tailing ponds and stuff like that. I don't think you'd find those in a greenfield implementation. But so I think that's the main thing is previously disturbed land is probably the main thing. And other things that come to mind is a greenfield wouldn't necessarily already have a big transmission line to it and a road to it, but mines often would. And so Gail, you
Yeah,
had some ideas
no,
too?
I was gonna say almost the same thing, that you know, we're thinking about kind of that former use that was on the site, the former mining activity that may impact the clean energy installation. And so that should be you know, kept in our mind whenever we're thinking about how we can reuse that site. And then any existing transmission, like Andy said, there may not be on green space as good of transmission options that might be available on a mine site. There also may be some existing roadways, kind of heavier duty roadways on a mine site that could lend themselves to a clean energy installation, and also, you know, potentially some buildings. And the buildings and the roadway can go both ways in terms of, you know, a help or a hindrance. But that's something that we would definitely want to consider when we're looking at a mine land. And that's what I had to say about that. We can go on to another question, an observation, and I have a thought on this as well, but Andy, let you go first. It said that many of the questions seem to kind of be related, you know, just more generically to, or sorry, the examples, more generically to not post-mine land sites. And it sounds like development is encouraged on virgin land sites based on the presentation, which is not true. Is there an adjacency clause to this that I might be missing? I did want to address that. The program is for mine lands. If you thought that, you know, maybe some of these examples had to do with not post mine land sites, it's really because we're trying to cover the site characteristics and the screening criteria that you may address for any siting project on any site that you're thinking about a clean energy project. And there are some add-ins to a post-mining type of site that we would want to consider. And Andy, you might have some thoughts on that as well.
No, I think that covers it pretty well.
Great.
But the example that we worked through is purely hypothetical. Yeah.
Yes.
Just a
Maximus mine is
springboard
hypothetical.
for a discussion. Yeah.
Right. Exactly. I'm scrolling down here. Let's see. So one thing I note is there are a couple questions about the FOA. Please feel free to send your FOA related questions. There's a FOA email in the chat. Those DOE is super responsive to those questions, so they'll get back to you for sure. And then if we don't respond to one of your Mineland TA questions, there's a CEML TA email address at the nrel.gov at the nrel.gov email address. You're welcome to send us an email, and Ryan and I will get that, and we'll be sure to answer that question. Quick question for Andy. What is the life of a typical solar facility?
Most of the PV modules have warranties of 25 years, and we typically use that for our analysis period. There is a standard on how to do life cycle cost analysis. It's ASTM E219, I think, which says the maximum analysis period for electrical equipment is 25 years. So we usually use 25-year analysis period. That being said, Lawrence Berkeley National Lab surveys developers to see what their anticipated lifetime is. And that has grown over the years from 20 years to now the average is 36 years. And so people are finding ways of refurbishing systems to keep them operational, repowering them with new inverters and new PV modules, and other ways to extend the lifetime well beyond 25 years.
Great, thanks, Andy. Another question that you might know the answer to, Andy, is does NREL have any analysis on the life cycle of solar panels near mine sites, which might represent some additional degradation? Or maybe if it's not near mine sites, do we have something that, you know, could be a proxy for that type of, you know, siting?
No, I don't have any data regarding the longevity of PV modules at a mine site. And in fact, we don't really have it really parceled out by different types of environment. You know, clearly very, very hot environments can take a toll on PV modules. marine environments with salt air can have an effect. There's environments with more soiling, like agricultural areas. But I can't think of anything about a mine site that just by virtue of being a mine site would have problems that wouldn't be, just general.
Great, thanks, Andy. Lindsay asks, are there instances where NEPA is not needed for development on mine-scarred lands? The reason I wanted to mention this question is because we do have a webinar coming up on NEPA. And so you'll get a lot of information on NEPA considerations during that webinar. If you check the NREL Mineland website where you found the link to register for this webinar, there's a date on the NEPA website and you can register for that NEPA webinar if you follow that link. And let's see, I am scrolling through. It looks like, well, we've got two messages.
If
Peter,
I could, on that NEPA
yeah.
question, if I
Yes,
could.
go ahead.
Yes, so
Andy.
NEPA's a requirement for anything that involves any federal funding or that requires a permit from a federal agency. So there's a good chance that a big project like this 100-megawatt project that we were looking at hypothetically, there's a good chance that it would require a permit from a federal agency and would trigger NEPA. Your question was about disturbed land, and I think there's a good chance that that PV modules on disturbed land might qualify for a categorical exclusion, but that's an outcome of the NEPA process. Like, you can't go into the NEPA process saying I have a categorical exclusion. You have to start the process, and that might be one outcome. Where you wouldn't have to do an environmental assessment or environmental impact statement. So I think, that the use of previously disturbed land is the prime opportunity here. Back to you, Gail.
Yeah, thanks, Andy. That's great. Didn't want to put you on the spot with that, but should have known you'd have an answer to that. And let's see, are there concerns with mining having taken place beneath clean energy development sites? Do any materials exist that discuss reducing risk from deep mines? Andy, do you have any thoughts on that in terms of, we're talking in some cases about mine lands that may have had some mining underneath that we're needing to think about the installation that's going above and how that underneath may impact what we're trying to do on the surface?
Yeah, not an expert on the topic, but I think most modern mining processes go through the subsidence as they're going through the mining. So it's more probably historical mines that I might be more concerned about. And certainly there could be risks. There could also be safety hazards, regarding underground mine things that are there. But
Yeah.
not my area of expertise. I'm not too sure. I think it would be highly site specific. If it's a surface mine or a pit mine, I think probably not. But I can think of some mines, here in Colorado where there probably is an ongoing risk of the ground movement and stuff.
Yeah, and Austin Counts, who asked that question, feel free to email us on that. And that goes out to everybody, is if you email us with the question at the NREL TA email address, that would trigger a response from us. And we're trying to answer every question we can and as well as we can on this webinar, but we've also got some experts that are more familiar with, topically that we could call on to help you out. Another question, what angle of slopes can a solar facility be built on? And is aspect, and I'm guessing aspect means orientation, important? Andy, can you answer that?
Yeah, if the ground is sloped towards the equator, so south facing in the northern hemisphere, that would be ideal. Then the slope would be working in our favor. Ideal slope is between 2 and 5 degrees. We don't want zero slope because we do want the water to run off in a planned way. And we don't want steeper than 5 because it becomes difficult to move the installation equipment around on. So that would be ideal, as more or less flat land, but with sufficient slope for drainage. That being said, photovoltaics have been installed on any slope. Like I can think of some cell phone towers which are powered by PV modules, where the PV modules are anchored to the rock face of a mountaintop. So it's possible, but it's all a matter of cost. The automated equipment used to drive the piles or to drive in the helical piles really needs flat land. So or that 5-degree slope or so. If it gets much steeper than that, then we're talking about more expensive construction techniques and non-conventional installation equipment, which could make the cost significantly higher for a large project.
Very good. Thank you, Andy. Let's see, last call for questions. We've got 4 minutes left. If you have your hand up, please type the question into the chat.
The ballasted racks that we've talked about can only be installed on essentially flat land if they're on a slope. The ballast will scoot down the slope. But the kind of things that would require those kind of ballasted racks are generally flat, like abandoned tailings ponds.
Very good. Okay, well, thank you everyone for joining us. Please join us for our next upcoming webinar. Jillian, did you have any final remarks?
Yeah, could you switch to the next slide, please?
Thanks all for your thoughtful questions. It was good.
Next slide.
Thank you.
Thank you, Andy. All right, well, thank you so much to our speakers today and to everyone who has joined us. As a reminder, this is the first webinar in the Clean Energy on My Land webinar series. We currently have 2 more webinars scheduled, and we'll be scheduling more in the future, so keep an eye out for those. We hope you will join us on June 14th for our second webinar, which will focus on NEPA considerations for siting clean energy on mine land. And then on July 12th for our webinar on environmental liability associated with developing clean energy on mine land. And we encourage you to sign up for OCED's newsletter to stay up to date on upcoming webinars and all other OCED news. Thanks again for joining us and have a good day.